Inside a factory in Luoyang, China, workers watch as battery cells roll off an assembly line built to mass produce a chemistry the industry spent decades dismissing as a lab curiosity, using a raw material you could scoop directly out of seawater. That is real. It exists. It's already entering mass production, and the world's largest battery manufacturer just staked its future on it. Every figure in this video comes directly from the company's own statements, peer-reviewed research, and specialist industry analysis, because a claim this dramatic deserves genuine scrutiny rather than just a viral headline. By the end of this video, you'll understand exactly what this battery can already do, where it genuinely still falls short of lithium, and why the company that built it is telling a noticeably different story than the one making headlines. Here's where this story has to start, because you can't understand why an entire industry started hunting for a lithium alternative without first understanding exactly what's been quietly wrong with lithium this whole time. Lithium-ion batteries power roughly 8 billion mobile phones, hundreds of millions of laptops, and a rapidly growing global fleet of electric vehicles and grid-scale energy storage systems, making the lithium-ion cell arguably the single most important piece of hardware powering modern life. Here's the problem sitting underneath that dominance, though. Lithium itself is a relatively rare element mined in only a handful of countries, and the vast majority of the actual refining that turns raw lithium ore into a usable battery cell happens specifically inside China, meaning even automakers and battery companies located entirely outside China remain deeply exposed to a single country's refining capacity and a genuinely volatile global commodity market. Here's exactly how volatile that market has proven to be. Lithium carbonate prices in China have swung dramatically over recent years, spiking to extraordinary highs, then collapsing, then surging again this year. A genuinely unpredictable price roller coaster that makes long-term battery cost planning a real headache for any manufacturer locked entirely into lithium-based supply chains. Think about what that volatility actually costs an automaker trying to plan years of future vehicle pricing around a single raw material whose price can swing wildly within the same 12-month window. It's the exact kind of unpredictable input cost that makes an entire industry actively motivated to find a genuinely viable alternative, not simply as a nice-to-have backup option, but as real insurance against a raw material they don't fully control. Here's the company that's now betting its future on exactly that alternative. CATL, formerly contemporary Amperex Technology Cumberlandite, the world's largest battery manufacturer by a wide margin, headquartered in Ningde, China. Here's the actual announcement at the center of this entire story. In April of this year, CATL confirmed it would begin mass producing sodium-ion batteries before the end of 2026, under a dedicated product line the company calls Naxtra, which the company says has already begun manufacturing at genuine industrial scale rather than remaining confined to pilot line production. Here's the mechanism behind why sodium specifically became the leading candidate to challenge lithium's dominance. A sodium-ion battery works on essentially the same basic principle as a lithium-ion cell, storing and releasing electrical energy by shuttling ions back and forth between two electrodes. But sodium itself is dramatically more abundant than lithium, found essentially everywhere on the planet, rather than concentrated in a small handful of mining regions, including directly inside ordinary seawater and the salt sitting in your kitchen cabinet. Think about what that abundance actually solves at the most fundamental level: a battery chemistry built around a raw material. This widely available anywhere on Earth simply can't be exposed to the same kind of geographic supply concentration or dramatic price volatility that's defined lithium's recent history, because no single country or handful of mines can meaningfully corner the global sodium supply, the way lithium production has effectively been concentrated. Here's the specific engineering breakthrough that pushed CATL's sodium technology from a promising but limited niche chemistry into something genuinely competitive with lithium for real vehicles. According to CATL's own chief technology officer, Gao Huan, speaking directly to reporters at an event in Beijing, the company's recent innovations increased the energy density of its sodium batteries by 50%. Specifically overcoming engineering challenges that had previously limited the technology, bringing the product to what Gao described as a genuine milestone stage. Here's why that 50% energy density jump matters so directly to whether this technology could ever power a real vehicle. Energy density measures how much usable energy a battery can store relative to its size and weight, and sodium-ion batteries had historically lagged meaningfully behind lithium, specifically on this exact metric, limiting earlier generations of the technology to less demanding applications like stationary grid storage rather than genuine vehicle propulsion, meaning a 50% improvement on this specific weakness represents exactly the kind of engineering breakthrough needed to make sodium batteries viable inside an actual moving vehicle, rather than only a stationary storage container. Here's the number that shows this technology has already cleared a genuine regulatory bar, rather than remaining purely a laboratory claim. CATL's sodium-ion batteries have already been certified to China's GB 38031-2025 safety standard, a mandatory Chinese battery safety regulation set to take full effect in July of this year, meaning this technology has already passed the exact same rigorous national safety certification process that lithium-ion vehicle batteries are required to clear before ever reaching a real customer's driveway. Here's the number that shows this breakthrough is actually moving through China's manufacturing base at real industrial speed, rather than remaining a slow-moving laboratory curiosity. According to industry analysis tracking this specific technology's cost trajectory, Chinese sodium-ion cell costs reached roughly 0.35 to 0.40 yuan per watt-hour during the first quarter of this year, with some of the most optimized production lines already reportedly reaching closer to 0.3 yuan per watt-hour. Here's why that specific cost curve matters more than any single laboratory performance number. One industry analyst covering this exact shift specifically noted that China's real breakthrough here isn't a single impressive laboratory parameter. It's the demonstrated ability to simultaneously connect materials, science, manufacturing equipment, production processes, actual assembly lines, real customers, safety validation, and genuine end-use application scenarios all together at industrial speed. Meaning this cost curve isn't simply a theoretical laboratory projection, it's what the analyst specifically described as an industrial organization curve, reflecting real factories, already producing real cells at these documented price points today. Think about what that distinction actually means for how seriously to take this specific breakthrough compared to earlier sodium-ion announcements that never fully materialized. A chemistry that only a handful of small startups are experimenting with in isolated pilot facilities is a fundamentally different, far less certain story than the exact same chemistry being pulled directly into the world's largest battery manufacturer's own mass production supply chain, with binding safety certifications and confirmed commercial customers already locked in. Here's where this technology is actually already reaching real customers, rather than remaining confined to press releases and laboratory demonstrations. By the middle of this year, Chang'an, a major state-owned Chinese automaker and Ford Motor Company's local manufacturing partner in China, began selling vehicle models fitted specifically with CATL's sodium-ion battery technology. Here's the number that shows exactly where this technology currently stands compared to lithium in real vehicle performance, according to the International Energy Agency's own analysis. A typical SUV fitted with a sodium-ion battery pack currently offers roughly 350 kilometers, or about 217 miles, of driving range between charges, compared to somewhere between 400 and 600 kilometers for a comparable lithium-based vehicle, a genuinely real, unresolved gap, but one that's already closed enough to make sodium-powered vehicles a practical option for a meaningful share of everyday driving needs, rather than remaining purely a laboratory curiosity, too limited for real-world use. Here's a second, genuinely important advantage. Sodium batteries bring specifically to cold climates. Sodium-ion batteries perform more reliably in extreme cold weather than conventional lithium-ion cells, a meaningful advantage specifically for northern Chinese winters, and for any other country facing genuinely harsh seasonal temperature swings, where lithium batteries have historically struggled with reduced range and slower charging. Here's how far this technology had already reached even before Chang'an's mid-2026 launch. Chinese electric scooter and light vehicle maker Yadea launched 4 separate two-wheeler models powered by sodium-ion batteries back in 2025, and cities including Shenzhen have already begun piloting dedicated sodium-ion battery swapping stations specifically to support commuters and delivery drivers, while JMEV had already begun offering its EV3 vehicle with an optional sodium-ion battery pack as early as 2024. Evidence this technology has been quietly working its way into genuinely real consumer products for several years before this year's larger CATL mass production announcement made international headlines, comparable to Tesla's own lithium-ion batteries. Think about why an independent, peer-reviewed comparison against Tesla's own cells specifically matters here. Tesla's lithium-ion battery technology has functioned as one of the industry's most closely scrutinized performance benchmarks for years, and a separate Chinese sodium-ion manufacturer's cells matching that specific benchmark, verified through peer review, rather than a company's own internal marketing claims, is exactly the kind of outside validation that suggests this broader shift towards sodium-ion technology isn't confined purely to CATL's own optimistic internal announcements. Here's the additional third-party recognition this technology received this year from a source with no direct financial stake in CATL's own commercial success. MIT Technology Review placed sodium-ion batteries at the very top of its list of 10 breakthrough technologies for the entire year, a genuinely significant industry-wide endorsement from one of the most established technology journalism institutions, specifically covering emerging science and engineering. Before going any further into where this technology genuinely still has real limits, it's worth pulling back and understanding why this shift is happening specifically in China's battery industry right now, rather than remaining an isolated CATL product launch happening in a vacuum. Here's the broader competitive context driving this shift. BYD, China's other dominant battery and EV manufacturer, is separately building its own massive dedicated sodium-ion production facility, meaning this isn't a single company's isolated strategic bet. It's an entire national battery industry simultaneously investing serious capital in the exact same alternative chemistry at the same moment. This is not a story of one manufacturer's marketing department getting ahead of the actual engineering. This is a coordinated industry-wide shift, with China's two largest battery companies both independently committing real manufacturing capacity to sodium-ion technology within the same rough time frame, precisely because the underlying economic case, cheaper input materials, reduced exposure to lithium price volatility, and genuinely improving performance has become compelling enough that neither company can afford to let the other establish an unanswered lead in this specific technology. Here's the honest concession worth sitting with directly, and it's a genuinely important one because it comes straight from the exact executive whose own quote is driving much of this story's momentum. When CATL's chief technology officer, Gao Huan, described this technology reaching a milestone stage, his actual words, reported directly from that same Beijing event, were that the era of compared to 400 to 600 kilometers for a comparable lithium vehicle remains a genuine, unresolved performance difference, meaning sodium-ion technology is winning specifically in cost-sensitive, cold climate, shorter range applications like city cars, delivery scooters, commercial vehicles, and stationary grid storage, rather than fully displacing lithium in premium long-range electric vehicles or consumer electronics, where every additional gram of energy density genuinely still matters. Think about why that distinction actually makes this a more credible story, rather than a less impressive one. A chemistry that's honestly winning a genuinely large and rapidly growing share of the overall battery market, while openly acknowledging exactly where lithium still holds a real performance advantage, is a far more durable, believable breakthrough than one that claims to have made an entire established technology instantly obsolete overnight. And it's notable that the exact executive whose company stands to benefit most from an overstated lithium is dead headline chose instead to describe this as two chemistries shining together, not one replacing the other. So here's the full picture, start to finish. Lithium-ion batteries built the modern electrified world, but remain genuinely exposed to concentrated mining and refining capacity and dramatic price volatility that's made the entire battery industry actively hunt for a real alternative. CATL, the world's largest battery manufacturer, answered that search with its Naxtra sodium-ion product line, achieving a 50% energy density improvement, clearing China's mandatory GB 38031 2025 safety certification, and confirming mass production will begin before the end of this year at documented industrial cost curves already approaching 0.3 WAN per watt hour on its most optimized lines. That technology is already reaching real customers, from Chang'an's mid-2026 sodium-powered vehicle launch to Yadia's sodium scooters and Shenzhen's battery-swapping pilot stations, backed by independent peer-reviewed validation showing a separate Chinese sodium battery matching Tesla's own lithium benchmarks, and topping MIT Technology Review's list of the year's most significant breakthrough technologies. What you're actually watching in this story is the same shift that happened decades ago when steel didn't replace wood. Entirely, it simply took over the specific applications where its particular strengths mattered most. While wood remained the better choice everywhere else, sodium-ion batteries appear headed toward exactly that same kind of durable coexistence with lithium, dominating cost-sensitive, cold weather, and shorter-range applications, while lithium keeps its advantage wherever maximum energy density in the smallest possible package still matters most. Lithium isn't obsolete, but for the first time in decades, it finally has a genuine, mass-produced rival specifically built to take the parts of the battery market lithium was never really the best tool for in the first place. If breakdowns like this, the real engineering and the real limitations behind China's biggest battery breakthroughs, are useful to you, hit like and subscribe, because there's more of this coming, including a closer look at how far sodium-ion technology's energy density can realistically climb once CATL's full-scale production actually ramps up later this year. So here's the honest question for the comments. Does a battery this much cheaper and more resistant to cold genuinely change how you think about buying an EV? Or does the real range gap against lithium make you think this technology is still a city car solution rather than a true lithium replacement? I read every single one.